will ask you to practice. So remember we work with some example as well. How to convert from decimal to binary and binary to decimal in decimal to decimal to octal, in binary to octal, in octal to binary, correct? This is something we worked last time, right? So decimal to binary and decimal to binary. So you work with some examples like this, correct? So how to convert binary to decimal and how to convert decimal to binary. Also, did I mention you have to convert binary to octal and vice versa, right? So there is a binary number groups, right? So as I told, those are the three bit multiple. So 2 raised to the power 3, 8 octal number. So if you have a binary number like this, base 2, and you need to convert it to octal number, base 8, then you have to reorganize the bits in a 3-3-bit patterns, like I are reorganized like this, right? So this is gonna be, if you put some more distance, so just rewrite them and have some displacement between them, so they can be regrouped in 3-3-bit formats. So once you regrouped, just write down their binary equivalent, their decimal equivalent. What is the decimal equivalent of 1 of 1, 5? What is the decimal equivalent of 001, 1? And what is the decimal equivalent 110? That is 6. Correct? So similarly, you can convert from another number, like from octal to binary number system. So octal number, for instance, is 735 base 8. So all you need to do, just rewrite them with some displacement between. And then once you have rewritten like this, 735, and then you're going to write down their binary equivalent for each digit. So what is the binary equivalent in 3-bit format? So first reorganize them and then write their binary equivalent, or 4 to 1 underneath of it, right? So what is 4 to 1? That is the binary equivalent. So for 7, 4-bit is 1, 2-bit is 1, and 1-bit is 1, right? All ones. This is 4 to 1. Okay, how about 3? Again, the binary equivalent for 3 is 011. Binary equivalent for 5 is 1. Correct?
Yes, ma'am.
Okay. So what if you have an hexadecimal number system? Okay, if I ask you to convert a decimal number system decimal number system into octal number, all you need to do, you need to follow the same process as you did for the binary number system, right? Conversion from decimal to binary. You divide it cumulatively by 2 because it was a base 2 number system. So basically, you divide cumulatively by n, where n is n is base of the number system, correct? Where n is base of the number system. So cumulatively divide 2. If it is a base 2 number system, cumulatively divide by 8. If it is in base 8 or base 16, then you have to divide by 16, correct? Hopefully you're following along. So you can convert. What if I have an hexadecimal number system conversion? So I have a binary number system, right? So number binary, and I need to convert it to its hexadecimal number system, base 16. Another method to convert is to convert octal into. There's a few more methods. You can adapt any one, whichever you feel comfortable working with. So here, uh, for base for base 8 number system conversion, if you need to convert from decimal to base 8, so you can do like first convert the binary, right? You can convert first for to convert. There are two methods basically. So one method is to convert base base 8 to base sorry base 10 to base 8. You can first uh, convert it into binary, and then you can convert binary to, because it's easy, right? Once you get to the binary, you can just reorganize the bits and can write down its binary equivalent for each of the 3-bit binary group, right? And then convert binary to,
decimal.
correct, to octal. Convert binary if in order to convert base 10 to base 8, right? So this is one method. Another method is uh, repetitively divided by base number 8, as you did it for the binary. So similarly for hexadecimal system, to convert hexa number, or to convert base 10 to base 16, all you need to do, um, first convert base 10. It's easy, right? Cumulatively division by 2 is easier than cumulatively division by 16, correct? Right? Or if you like to directly divide it by 16, that's totally fine. So first convert base 10 number into base 2 number, then convert base 2 number into hexadecimal, because communication between hexa and binary is always easier for us, right? Conversion between hexa and binary and octal and binary is easier. So in order to convert any decimal to hexa, you can simply first convert that number into the binary, and from binary you can change it to the hexa. Or if you don't like to go with two-step conversion, then you can just adapt one-step conversion, like any number you have it, right? So for instance, 32, so you can divide it by 16. What is the remainder? 0. Then 32 in decimal is equals to 20 in hexa, right? So you simply take LCM with 16 in order to convert that number from 16 to hexa. So that is a one-step procedure. Or if you're not feeling the number is bigger and you don't like to do the LCM of 16, then take the LCM with a 2 and then convert that binary number into hexadecimal numbers using the same method. Okay. Okay, so question if you have, clear or not? Hopefully it is clear.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Uh, conversion from binary to hexa, the same method as you have adapted for octal to decimal. All you need to do, uh, regroup them, right? Regroup them means reorganize them, or rewrite the number, the binary number, with some displacement. So you can group them in 4-bit patterns like this: 4-bit pattern, 4-bit pattern, correct? So once you have made the group of 4 bits, you're not going to change the bits, right? You're just only grouping them in 4-bit format. Then, every 4-bit nibble can be binary, can be rewritten in their hex cycle. So 101, so you use this little chart here, right? For 102, 0 to 9, the same as the binary number, right? Excuse me. But from 10 to 15, so you remember 10 is equals to letter A, 11 is letter B for hexa, decimal 12 is letter C, decimal 13 is letter D, and decimal 14 is letter E, and decimal 15 is letter F. So you can just write down A, B, C, D, E, F, A to F for your quick reference, right? A to F, and then 10 to 15. Easiest way to remember. Is that easy? Right? So whenever you need to refer the hexa to the rest of the numbers from 10 to 15, so write down A to F on one piece of paper where you're working on, and then 10 to 15. Okay, then write down the number. What is the binary equivalent for each of them, right? For 1011, this is This is binary, this is decimal 11, right? So you write down decimal 11 here, 100, this is decimal 12, and 011, this is decimal 5. Okay, once you had their decimal number, you can just simply write down their hexadecimal equivalent. So 11 means B, 12 means C, and 5 means 5, correct? So this is how you can convert from hexa to from decimal to hexa or vice versa. Okay, vice versa in a sense like you have an hexadecimal number, right? You have an hexadecimal number, and then uh, you need to convert it into its binary equivalent. Okay, so all you need to do follow the same procedure, a little bit different, rewrite them. This time hexadecimal number. So D5F with some displacement, and then write down their binary code for binary each of the hexadecimal digit. So what is the binary code for B? B for 13. Okay, so what is the binary code for 13? Check your table. You will see that there is 1101. So what is the binary code for 5? So check your table which you have written in earlier class, 0101. 4-bit binary pattern. You remember that every hexadecimal number is equals to 4-bit binary. Just remember this for this conversion. Okay? So 4-bit binary or a nibbler. 4-bit binary is a nibbler. Okay, so 1101. So this is 12, right? So this is 13. So you have written there D and 5, and then F. F means all ones. All ones means F or 15. All right. Makes sense? Do you have a question at this point?
No, ma'am.
No, ma'am.
Got it?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes, ma'am.
Yes,
So,
ma'am.
okay. So, um, let's get to. Okay. So, I have a few examples here for you to look at that examples. Um, okay, the point is if you already have base 8 number and you need to convert it to base 10. Well, the pretty much the method, the rule and principle are same from to convert what you did from binary to decimal and decimal to binary for other number system. All you need to do just change their base, right? So if it is a base 8, so instead of using 2, you use the base 8 instead of using uh, uh, or you can use the 16 if you're converting from base 16 number system. Okay, so uh, let me get to this. So this is the example I have it for you to consider. Uh, 5, 3, 7, 0, 8. This is in base 8 number system. It's an octal number, right? Base 8 number system. So base is mentioned as a subscript, not as a superscript. So what you need to do, you need to convert this base 8 into base 10. Remember, what did you do to convert base 2 into base 10? Do you remember that? So you simply multiplied each number by its weight, right? So what is the weight for each number? You know, all right. So, I think I X out this document and then open it again. You guys following, right?
Yes, sir.
Hope,
Yes,
Yes,
ma'am.
hope,
ma'am.
hope, hopefully.
Yes, ma'am.
Okay, good. So this time I have this number. Just pay attention. No attention. This attention is good enough. So 53702 base 8. So all you need to do, you when you're converting from base 8 to base 10, then just multiply each number by its weight. So number is 5, 3, 7, 0, 2. So what is the weight for this number? In octal, it is going to be 8 raised to the power 0. This is 8 raised to the power 1, 8 raised to the power 2, 8 raised to the power 3, 8 raised to the power 4. So this is the weight for this. So you multiply each number by its weight like this, right? 5 multiplied by 8 raised to the power 4, 3 multiplied by 8 raised to the power 3, 7, and so on. Then you add them together, add them all, okay? So 8 raised to the power 4, you do a little math, and then you multiply it by 5, you're going to get this number, right? So 8 raised to the power 0 is 1, which is 2. Okay, so what you're going to do, you understand this method, right? So you multiply each of the weight. This is the weighted value. So this is the weighted value for each digit. position. 8 raised to the power 4 is 4096. 8 raised to the power 3 is 512, and so on. So 8 raised to the power 0 is 1, correct? Then once you get this 8 raised to the power values, which is this, then you multiply them by the corresponding digit value, which is 5 in this case, 3, and then 7 in 0, and so on. And then add them together, right? So wherever you find 0 is going to be ignored, right? So wherever you have, whether it is a binary number or hex, so this is going to be 0. So once you add them, check it out if you have the same answer or not. Check your answer.
It's same,
Do
ma'am.
this. Do the calculation at your end. Okay. So you got the same answers. Okay, good. All right. So what is next then? Now I have a little different number, but it is also in octal. So 434368. Get their binary, get their decimal, get their decimal, and get their decimal. Solve it and let me know.
286.
So what I ask you to uh, write in chat box. Chat box. 286. Okay.
Yes.
So for each number, right? For like 1, 2, 3, 1, 2, 3, 4, and 5 to 4. So I want at least everyone should be giving me at least one of an answer for one of them. I have three numbers. Pick anyone and give me your answer.
First one on 286.
Okay. Are you using calculator? Hmm?
Manual, ma'am.
No, ma'am.
Well, you can use to verify your answer, but first learn how to do it manually. Just like when you learn the number system, you first learn how to add manually and multiply manually, and then you verify it with calculator. Correct? So you have the both versions. Okay, so please write down your answer in the chat box. All right, got it done? Awesome, beautiful. Okay, so what is next then? Oops. Trying to look both versions, like the text chat and in my document, if possible. Can I put it here? Yes. All right. So I have another number from hexadecimal to base six, base 10, right? So now let's convert from hexa to base 10. So this is the number I have. 5, 3, 7, C8. I just rewriting to have some space between. This is base 16. How do you know? Well, easy in this case because you have letter A there. All right. So what is the what to do to convert it into base 10? Same method, just the number power base number is going to be changed. So what is the weight for this? You know the weight, how to write weights. So, remember the weighted position for every number. Every number has its weighted position, right? So all you need to do, write the weight. This is 16 is to the power 0, 16 is to the power 1. How about this? For 7, what is the weight? 16 is to the power 2, 16 is to the power 3, and this is 16 is to the power,
Four.
right? So this is the weight for each of the digit position. So every digit position has their weight in their number system. So if you're working with base 16, then write down their weight in base 16. So once you know their weights, multiply it by their number given, and then add them together. That's it. So weight is 16 raised to the power 4. You multiply by number, which is here 5377CA. So multiply 5 by their weight, which is 16 raised to the power 4. 3 by its weight, which is 16 raised to the power 3, and so on, right? So do your little math. Use your calculator to get the 16 raised to the power 4. It is 6536. This is very common number in binary code. 65536. This is 4096256, and then 16, and then 1. Correct? So once you get the weight from your calculator help, then you multiply it by their numbers. 5 multiplied by its weight, 3 multiplied by its weight, and so on. Right? And then add them all. Add them all. What you gonna get? Check your answer. Use your calculator to do this little math quickly. You don't have to do each and every step manually. All right, question. If you have, you can ask me at this point. Is that it done? Okay. So if you're good at here and no question, I can move to the next. So I have, once you understand how to convert from hexa to a decimal, so I have one more example here for you to practice. For instance, 4B6, 1234, and EDA. EDA, right? So what is their decimal equivalent? 4B6. How are you gonna work out? method is saying. Oops. Okay, so this is the let me put it here. All right. So trying to convert just the same method what I mentioned. Try to convert any at least one of them or two of them into their base 10. Just quickly do it. Your math. So type in your answer in the chat box. For do mention the number 4B6. I got an answer from Muskan. Muskan is helping everyone. Good. Do mention what number you're writing equivalent. Otherwise, other peoples who just join in with their rubbing eyes and say, "Hey, what's going on there?" I don't know. 1, 2, 3, 4, and that is base 16. And then what is their base 10? 1206, correct? Question? Just trying to grab something. All right. Okay, so everybody is okay up to here, right? 1206. I would say write down in a way like 4B6 is equals to what? 1, 2, 3, 4 is equals to what? EDA equals to. So you can match to. Oops, I think I send it echo numbers to particular person. Doesn't mean that. Let me repeat it again. 6. Okay. Try it out if you haven't done it before. And I encourage you to check your answers, tally your answers with your friends and class fellows, just in case if you're doubted. Hey, am I done right or not? So check your answer with your class fellows. So here is an open chat is going on. So see what the other people are saying. Do you agree with them or not? You don't have to. All right. Okay, let me quickly explain this one as well. Um, what if these numbers I had given you earlier already converted in hexa? Now you have a decimal number like 215 and convert it in octal and hexa. So as I said earlier, just divide every time by 8 until and unless you get something which is less than 8 or 0. So I had a number 215. All you need to do is divide it by 8. You got 26 here, so remainder is 7. And then 26 divided by 8 again. So 3 it's a 24. So what is the remainder? Remainder is 2. Can we further divide it by 8? No, because the number is going to be in fraction. So we stop here. So the number equivalent would be, we're going to read like this, 327. 327. So 215 in base 10 is equals to 327 in base 8, right? So you try 682. Got it?
Yes, ma'am.
Okay. So
Yes, ma'am.
try,
Yes, ma'am.
okay. Did you try 682? Same method. Divided by 8 each time until and unless you get something which is less than 8 or 0, right? Um, now, what if I have to convert decimal 215 into base 16? So this time you're going to divide it by 16 again and again until you get the remainder quotient. Quotient, this is quotient, this is remainder, until you get a quotient which is less than 16 or 0. So 215 divided by 16, take the LCM, you're going to get 16 1 by 16 and 16 3. So it goes 3 times. So what is the remainder? 7. Again, as you cannot go further, so you're going to read like this, 3 7. So 215 and decimal is equals to, okay, 13, 13 is less than 16, right? So remember 13 means D, 13 for the D, right? In hexa, so you're going to write down its equivalent, D7. Make sense? Hopefully. Oops. Oops. It's trying to readjust it. Okay. All right. So, question if you have, if not, then try it at your site. This is the decimal number and try to get base 16. Okay. So we are pretty much done with the number system, right? Conversion. So I'll give you an assignment. Uh, if you have question, you can ask, or just try to practice a few more numbers as you see on my screen. Or if you like to have a break for 10 minutes. All right, if you are good to go further, so get this number. Just a little bit more example for binary 2. Binary to base 8. Okay, what if I ask you to convert binary to hexa? So you some simply reorganize the bits in 4-bit nibbles and then write their binary, their hexadecimal, like this, right? All right, so hmm. So you guys are very good in maths, right? I'm
Yes,
getting
ma'am.
it. Huh?
Ma'am, we all are good at maths.
All right, that's good. That's very good. Maths is basically the father of all you know, all field, I would better say. Wherever you go, maths is there. Uh, all right. So assignment is ready. I have a few questions there. I'll post that assignment sometime today on D2L.
When's the submission?
So all you need to do, you use the Word document to just like I am showing you in this Word document, right? So how to convert this number in hexadecimal into binary, right? So you organize it and write down their binary form. So you need to do all the assignment. You don't need to like do the fancy things like I had it here for you. Just just for the attraction results, right? Um, you need to work with the Word document. And if I ask you to convert a number into decimal number into its binary equivalent, so you follow the method of LCM using base 2, or if for octal using base 8, or for hexadecimal base 16. But everything should be done in Word document. I'm not accepting assignment in an handwritten format. Okay, so this assignment I'll post it on D2L today sometimes, so you can look at it and answers the questions. So time I'll give you few days to solve and submit it on D2L.
Excuse me, ma'am.
Yes,
Ma'am, do we just write answers?
no, there is no point to give you assignment then. No, it's just in chat box is fine. But when you're doing assignment, you must show all the steps like this, right? So you must show all the steps. Otherwise, you're not going to get the credit like this. If it is base 2 or base 8 or base 16, then you're going to write down base 2 here, or base 16, then you're going to write down 16 here, like this. Well, you don't need to do the cloudy comments, but you have to show me your calculation if you want the credit for that, whether it is from binary to octal or anything. So that's going to be your first assignment to work with the binary, octal, and hexadecimal number system. Okay. So question if you have, you can ask me. Well, I need a quick break for 5 minutes. I'll be right back, and I'll teach you some new topic after that. Okay.
Okay,
Okay,
ma'am.
ma'am. Thank
Okay,
you.
ma'am.
So
Ma'am.
it's 8:40. So we're gonna be continuing by 8:50. Okay.
Okay, ma'am.
Okay, ma'am.
Yes, when you're doing the conversion, um, send answer to who everyone, not just particular to me. Okay, so other people can see what is your answer, and you can see the other people's answer. Okay,
Ma'am, actually, I'm confused.
what happened? Why are you confused?
I don't know it is wrong or right.
With your answer, Muskan is speaking, right? 682.
Yes, ma'am. 152.
So 682 is
Can you do it, ma'am?
yeah, 682 is a decimal number, right? I
Ma'am,
guess.
I convert to octal.
Okay, this one. What was the confusion point? You 68, write down 682,
Yes, ma'am, it's decimal and 152 is octal.
and you divide it by 8 like this.
Yes, ma'am.
Simple.
Is it wrong or right?
What's your answer? 152. Sounds like okay to me. All you need to do, read from the bottom. Always, whichever conversion you do in the LCM format, always read from the bottom.
Can you tell me, ma'am, it's wrong or right?
It's correct. Yes.
Thank you, ma'am.
Uh, 682 is one Muskan. It is 1252. Correct. Yes, it is the correct. And if you're going to convert the same number into hexa, then it's going to be 2AA. Try it converting in the hexa. All right. So I think we still have left 2 minutes with the break. Okay, if you're done with the break, um, I'm going to teach you some new topic. Excuse me. Okay, you all set? Shall I continue topic?
Yes, ma'am.
Okay. So, so we have done with our topic, the first one, conversion between number systems. Now let's have a look at the computers. Have you ever opened a personal computer? Have you ever seen a computer inside? Any
Yes,
of you?
ma'am.
All of you? Really? Excuse me, interesting. So what did you see there? Yes, what did you find?
Motherboard, graphic card, power supply, hard drives.
Well,
Fan.
you all right. So you know everything about computer, right? Kosh?
Yes,
Yes,
ma'am.
ma'am.
Okay, how let me do a quick poll. How many of you have opened a computer and have seen different parts? I'm not saying that you fixed it and you replace it. Just have opened and seen what is inside. Please put up your digital hand. 4, 6, 7. That's okay. Not bad. 7 people have seen inside out of the 57 class. Rest of the 50 people say, hey, I don't know what she's talking about. I have never seen inside the computer. Shall I supposed to? Well, it's not a requirement of a mandatory requirement for to start this course that you must have seen a computer before you start learning. What you're going to learn in this course, right? If you know something already, that's going to be helpful and make your learning process more faster. If you haven't seen anything inside the computer, like 50 people say didn't say anything, they are quiet and it means they didn't see anything inside the computer. Am I right? The people who did not put up their hand.
Yes, ma'am.
So Arjun, Gurinder, Harjot, and let me see who else. Kapil, Akash, Neha. You know as well, Neha. Really? Anish. Okay, very good. And you have told that I have seen your power supply, motherboard, memory, etc., etc. So other people's may might be scratching their head, but won't scratch your face at this point. Okay? Don't worry. Hey, what they're talking about? Scratching head is fine, but scratching head is totally not fine. Face is okay. All right. So, what I can suggest you, all of you, don't have to agree, but my suggestion is I'm not forcing you, as because there is a pandemic in India as all over the world. Um my suggestion is if you can just try online, a scrap computer, any scrap computer. You know, there are many people that are dumping their uh, electronic stuff like computers online, and they're saying take it for free and rid of it, right? So because computer they cannot throw it in garbage bin, right? Someone want to throw it and want to get it like it might be quite working, but they don't really want to keep it because they got a Surface Book or something like that, and they just need a more room in their house or table or office area. Then you check it out. Someone is selling out maybe for $20 or something, a used computer or old computer, right? My suggestion, if you really want to enjoy learning in this course, you know, because you can watch on videos. I'll show you the demonstration, YouTube demonstration or something like that. But when you touch the things by yourself, that's possible, right? So try if you can find some old computer, scrap computer online, and try to get it as like in 1 week time or so. So when we can come back next week, so you have your old or used computer. And then what I suggest, you don't open it, don't turn it on, but you can unscrew the contents, and I'll tell you the steps how to do that. Okay? You understand what I mean? But that's not a mandatory requirement, and that's my suggestion. Let's give you an like an a clear when you do give you an hands-on practice. Well, I'll show you on my computer screen. I'll show you the demonstration, a video demonstration, but I cannot just do it a computer. Hey, this is the computer and how to fix it and how to open it. Not really possible. You're not gonna follow my pace because you are far from my station. Okay. All right. Do you agree or not? All right. So that's up to you. That's just a suggestion. It's gonna be helpful. I'm telling you. Anyways, so let's focus. What is the personal computer? PC for personal computer. Well, you may have a desktop computer, may have a laptop computers, but the things what I'm gonna tell you that is general, whether it is PC, a desktop computer or a laptop computer. So I'm gonna explain you how to keep personal computer components safe in different components inside the computers in the electrical and ESD safety. So hopefully I'll cover those first three objectives today, right? There's a lot more, so we cannot just finish everything in one sitting. I'll explain you step by step. What is the personal computer? How do you define a personal computer? Someone can tell me in their words. Speak up if you can.
It's a computer that
What is
uses
A
some.
computer that we use for our personal use.
for personal use? Okay. Personal use like emailing, for instance. Anything else for
Like
gaming?
there's no other, like there's no one else can log in it, and it's for
Hmm.
like only for our use.
Oh, personal is, oh, that's my computer. Don't touch it. Okay. This is what you're saying, right? Exactly. So how do you do that? By not giving them your password. This is my computer, right? So, well, they can touch it, but they cannot get into the system. Well, they can open it. Yes, they can unscrew your computer if you're not at home, right? Right? They dismantle, hey, I'm also taking that course. Let me see what is inside that computer. Let me open his computer. He's not at home. And then play with that and then unscrew and unscrew everything in half an hour and put it back without like someone cannot use it, but someone can open it, right? Well, there is a trick. You can protect that. So this thing, those things, protecting your hardware as well, because that's also a set, right? Very good. So I got a very um, formal kind of definition. Personal computer, small computer, okay, with the is microprocessor. Wow, microprocessor is also there, right? And designed for use by an individual. Excuse me. Pretty good definition, Bhavesh. Yes. Anybody else? That's it. Just two people knows about computers, but everybody using it. Now you're going to learn in this course what it is, what I am using, right? All right. I have pretty much similar definition, a little different. You may find it. Um, well, personal use, a computer is personal computer can perform different tasks. What task? Like you just have done it during this class. You did your calculation, right? So you use a Word document, you use a notepad, you write it down there, right? And you may use the built-in calculator to do the multiplication, raised to the power, etc., etc. Who was helping you beside me? Well, your computer, right? Your computer was helping you, providing you all the necessary tools which you need to do that calculation, the mathematical calculation, right? So computer is a device which is used to do some calculation, programming. Uh, so you can program a computer, right? Well, you're using operating system, right? Windows operating system, and you're learning it in some other courses about hey, what it is. Well, operating system is nothing but an program, computer program, right? Computer program, but someone else has written it, not a single person, a group of people over the time period, they have written computer programs. The computer programs basically you can instruct a machine, hey, do this and open email for me, open a Word document for me. I'm going to write down in a formatted text. I'm going to write down an email. I'm going to chat with my friends on Zoom, or I'm going to attend a class on Zoom and I'm going to go to D12, all those things, instructions, right? So you're using particular platforms to do the different things like Zoom program, that's a program application. Word is an application program. Explorer is an application program. So a computer is a programmable device that can store, retrieve, and process data. Store, retrieve, and process data. Right? Those are three main jobs of the computer, correct? So it's an electronic device that can uh, do this all three main tasks and also output the data. So everything computer understand, as I mentioned earlier, that is in the binary format. So binary form because computer you want to store something 10101000000111, right? So this is how they store. You want to retrieve something, this is how it receives. You want to process something, this is how the format it processes the information. Everything. This is what we binary number system. Computers say this is my language, which we call machine language. Machine also has a language. Really? Yes, machine language. We understand the language I'm writing, right? English language. But computer don't understand English at all. But we cannot teach him with English language. That's another problem, right? All it understand is 101010. Correct? So it's an electronic device um, which process, re- retrieve, store binary information according to the instructions given to it in a variable programs. In a programs, you say, hey, I want to add X and Y, right? Give me Z, right? So you write in this equation and computer will say, hey, what is X? Give me X. Okay. So then you're going to provide X value, you're going to provide Y value, and then, for instance, X is 10 or Y is 2, then you say, hey, X is 10 and then Y is 2, then computer gonna give you Z is equals to 12. Correct? That's a basic operation. But you give an X in a language as you feel comfortable to, and Y in a language as you feel comfortable, which is an English like language, right? So computer interpret this information in binary. Hey, this is what they want. Binary 2 and binary 10, right? And then I'm gonna add them to in binary addition, and then it's gonna give you the result, right? Which is 1100, correct? So that is what it provides. But the question is, calculation is done by computer, okay? Processing, this is processing. It asks you for X and Y, right? And well, store. Well, you gave computer X, right? You gave computer Y. Well, where it's gonna keep it? You say, okay, this is X, this is Y. Okay, where the computer gonna keep this X and Y? In ear or in pocket or in drawers? Where? What do you think? Or there is any special device inside the computer which stores that information you're providing? X is going to be stored in where? Someone can tell me. What do you think?
RAM and ROM.
Okay, Javan, not in ROM because you cannot directly write or ordinary information in ROM. It's going to be stored in memory, which we term RAM. I'm going to explain those things in different topics, right? Under different sections. So it's going to store in memory. Like we store information in our brain. And we say, hey, he has a very good memory, can remember everything, right? So maybe your parents have passed kind of comments to you, right? So memory means which stores information, right? But what happens? You're listening me today, right? And you come back tomorrow, you forget. I forgot everything. I don't know what she said yesterday, right? Happens like this. Well, It could, because your mind is involved in some other task. From this class, you go to the class two, and the class two teacher tells you blah 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 kind of things, and you're gonna listen everything from there, and then you go to the class three, and then so on, right? And you come back tomorrow in my class and say, I'm gonna ask you, what did I teach you yesterday? You're gonna say, hey, I don't exactly remember, right? Maybe it happens. Then, because in our memory, human memory, some information permanently stored for a long, permanently stored means for a long time period. For a long time, there is a spatial area in our memory, which stores everything for a long time period, right? And there's a spatial area in our memory. We cannot just like draw a line, say this is the area where it stores information permanently, and this is the area where it stores information temporary. Not really like this, but it happens in human brain. Some information lasts for longer, and some information was just quickly washed away, and say, hi, hey, I don't remember exactly what happens to 2 3 days before, what was explained or discussed, maybe, right? Then there's another solution for you. If you don't remember, we say, hey, you're not supposed to remember each and every word I'm telling you. But then another way of memory is permanent kind. This is right. If it is not that long lasting information in your human, in your sweet memory, then I would say make a note, right? So use the notebook and write down number one, number two, number three. So topic one, discussion in your words, if whatever language. What I suggest, encourage you to write it in English. That's easier. Well, the language you write it, you will feel comfortable to tell other people's, right? What you understand. You feel comfortable what other people tell you in English to explain. So write it in your English style, what I'm explaining each and every day. So in your notebook, and you save the document somewhere in your, if you have notepad, iPad or something, some tablets, right? Tablets give you an option, like I'm using a stylus right now to write down all those kind of things on my slide. So you write down on a piece of Word document, and you save it the Word document, right? So this is what we say. You're gonna say, hey, this is my um, chapter one, right? Chapter one, or day. What is a day today? This is day four. For instance, you say day four discussion, and you stored it in your hard drive or somewhere where you can retrieve it back. So this is another kind of memory. Okay? So next time you are studying and you need that information, you open that document and this information is right away there, right? So two type of memories you are also working. One is your human brain, right? It's your sweet brain, and you listen information. You try to store as much as your brain can afford, right? And then all depends upon its capabilities, and everybody has very good memory. Everybody has very good, beautiful brain. This is what I believe. Uh, and then you write it down. Another way is you permanently write down the information. So this is how the human works, right? Computer is just took this kind of human behavior in a machine format. Human has a brain, human has a memory, human can think, human brain can manipulate information, can calculate, can store. So the peoples who invent the computer first time, they transform this human ability to some extent into the machine, right? And machine can see as well, yes, right, correct. Uh, so now machine also have two type of memory. One where where they store the information for some duration of time, as long as the session is interactive. How much time is left? As long as session is interactive, you're working with computer, so everything is stored there, correct? But once the session is complete, like I'm going to X out the Zoom, well, might be many things gonna be washed away, right? One second. Okay, so are you guys following along, right?
Yes, ma'am.
Yes,
Okay.
ma'am.
So this is how our system works. We store information for some time period, we manipulate it, we retrieve it. Retrieve means tomorrow you come back and we discuss for a quick revision. That's a retrieval, right? So computer has same pretty much not to the level what we do, but some little lower level. But it does stores information for temporary, for permanent, and process information, and next time you can retrieve it, right? uh, so computer is basically designed to accept data input, input information, right? Perform some calculation.
Actually, I
Everything
can make
computer
any easy
does
payment with just
is
like one
math,
government
either
or
it's a
then chal bani
mathematical
jata
or
hai.
in mathematics, right? Some
Okay,
mathematical
पैसा
operation
सही मतलब देख
or
लेते
some
हैं.
logical operation, right? Thus, everything computer does. Either it is a mathematical or a logical operation. Those are the two main things, right? Mathematical means like add,
Galaxy
subtract,
सारे यार बहुत
division,
मूवी देखने मिलते हैं.
correct? Uh, I think, let me get to the things. Am I sharing? Oh, okay. So this is what the computer basic definition of computer. What the computer can do. Computer can input the information. Next time you define the computer. Computer is a machine which takes the information, which store the information, retrieve it, and process, right? And computer is a machine which performs mathematical and logical operation, correct? So write down in somewhere where you can remember. Next time some people ask you, anybody like other than me, right? So you can quickly respond. Computer is a machine which takes the input, store the information, retrieve and process the information. Or it can performs mathematical and logical operation. Make sense? So variety of computers we have surrounding us, like mainframe computer, desktop computer, laptop computer, tablet, server, smartphone. They all are the variety of computers, different shapes and size, capacity, capability, applications, right? For instance, if you are moving around from from home to work or home to school, and you need a computer to carry with, so you prefer to use a laptop computer then, right? So if you are staying at home most of the time and you're working from home or studying from home, then you might be using a desktop computer, right? or a laptop as well. There's no problem using laptop in that application as well. So you might be using a smartphone, for some of the applications, say smartwatches. You might be using IoT devices. IoT, have you ever heard about IoT device? That's the latest one, latest trend in computer era. So Internet of Things. Internet of Things. Have you ever heard about it? That's a beautiful thing happening in this world, in the world of computer. If you have heard about, like, in some place in world, peoples are developing a smart city. A smart city. You heard about a smartphone, a smartwatch, a smart machine, a smart TV, etc., etc. Everything peoples are making it. It is smart, right? It's smart. Have you ever heard about a smart city? A smart city. Anyone? Smart city is going to be our future places to live, where we have. Are you guys listening me and following me?
Yes,
Right?
ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
All
Yes,
right.
ma'am.
Okay.
Ma'am.
Thank you. Okay. So that is a city or place, our future city, future living space. If we all safe from pandemic, hopefully. So that's going to be the city of IoT, right? Internet of Thing. Well, where everything is just in smart. Your highways is smart. Your road's gonna be smart. Your car is smart. Your home is smart, right? Smart means you're using technology, digital technology, processor, and you're asking everything to follow your instructions, digital. Take your instructions, listen you, follow your commands, right? This is what the computer does, right? So this is what we call Internet of Things, which basically controls the devices using Internet of Things, right? So that's our trend. It's our this is our future destiny, right? So far, so you're quite familiar with the smartphone, smartwatches. Hey, I got a new smartwatch. That was my birthday gift. What it is? Well, I can receive emails, I can make a call, I can go to the Zoom from my smartwatch, right? So everything is now on your wrist, right? So that's a technology size, right? So as technology is booming and evaluation is there every day. So the size of the things are getting smaller. Wi-Fi controllers, lights. Yeah, you're correct, correct. Yes, like you're controlling lights and bulbs and your homes and car using your smartphone, right? Hey, did I turn off my home lock? Okay, check with the smartphone, right? So this is what we call Internet of Things. All right. So this is we going to carry on. Uh, Question if you have. Computer basically consists of hardware and software. Hardware means which you can touch. You can touch your laptop, right? Keyboard, mouse, monitor, and that's the main computer device, right? So that is what we call hardware. What do you see on the display screen? You see some color screens here on my display. That is software, right? Software which cannot be touched but can be processed, can take your information and can communicate, help you to communicate with the machine. This is what we call software. Hardware basically a physical equipment such as a case, storage devices, keyboard, monitor, cable, speaker, printer, etc., etc. Any accessory, any other computer accessory that is in hardware. Okay, software is operating system, as I said, and other programs. Well, operating system has its own class. its own class. We normally don't put it into the computer program class, but it is a computer program. Programs means like Microsoft Office, Zoom, for instance, Explorer, those all are computer programs. So operating system basically instructs the computer how to operate, what to do, right? And how to do it. All those things. That's the operating system. So programs and applications basically they performs like you're using Zoom. Well, Zoom cannot do addition, subtraction, multiplication, right? Zoom purposes Zoom. You're gonna say, hey, Zoom purposes Zoom. Well, it is a virtual meeting platform, right? So it's a dedicated software. But if you want to do the addition, subtraction, you cannot use Zoom. You need to write your assignment. You don't need to use Zoom. Then you can get in help from Zoom, but cannot do it inside it, right? So we don't have any document application inside. You have to go to Microsoft and pick the right application like MS Word or something like that, and then you perform your different functions, right? Okay, let me stop at this point, and hopefully we will continue in this topic tomorrow in our next meeting.
Ma'am,
This
attendance is pending.
okay.
जोबन लो आ गया भाई अटेंडेंस ਸੁਖਮਨਪ੍ਰੀਤ ਯਾਰ ਇੱਕ ਉਹਦਾ ਘੈਂਟ ਆ ਆਪਣੀ ਕਲਾਸ 'ਚ ਹੋਰ ਕਿਹੜੀ ਆ ਗਈ
Okay, I'm going to roll call your names. Please respond if you're there.
Okay, ma'am.
So
Which
today's
smartwatch did you get on birthday?
huh?
As you said, you got a smartwatch on your birthday.
Not for me, not for me. I'm telling you for you. My birthday is in this month, but nobody's gonna give me that expensive gifts. I know. That's an expensive one, you know. Anyways, that's an example for you guys. You guys are rich in India, right? Okay, here.
No, ma'am.
Really?
Yeah.
Okay. That's another topic. I don't want to touch it at this point. Akash Deep is here.
Present,
Uh,
ma'am.
okay. Amandeep Kaur.
Present, ma'am.
All right. So Amanveer Singh,
Present, ma'am.
Arjun,
Then, ma'am.
Arshdeep Singh,
present ma'am
Gurinder Singh,
Present, ma'am.
Gurleen Kaur.
Present, ma'am.
Everybody is present. Gurmanjot Singh,
Present, ma'am.
Harmanmeet Singh,
Present, ma'am.
Jaspal Singh,
present ma'am
Jaspal Singh.
present ma'am
Okay. Jatanpreet Kaur.
Present, ma'am.
Okay. Jobanpreet Singh.
ਜਿੱਦਾਂ ਵੀ ਹੋਵੇ
Present, ma'am.
Present, ma'am.
Jobanpreet Singh number two.
Yes, ma'am.
Okay. Both are present, right?
Yes, ma'am.
Karanbir
Yes, ma'am.
Singh. Karanbir
Present, ma'am.
Singh. Kulvinder Singh.
Present, ma'am.
Okay. Lovepreet Kaur. Absent.
Go.
Lovepreet Singh.
Present, ma'am. Lapri Singh, present.
Manisha.
Present, ma'am.
Manjot Kaur.
Present, ma'am.
Okay. Manjot Kaur number two.
Present, ma'am.
All right. It's a pretty long list. I have. Hmm. Mahadeep Kaur,
Present, ma'am.
Muskan,
Present, ma'am.
Neha,
Present, ma'am.
Parminder Kaur,
Present, ma'am.
Prinkle Jot,
Present.
okay, Ravinder Singh,
Present, ma'am.
Rabanpreet Kaur,
Present, ma'am.
Simarjeet Singh,
Present, ma'am.
Sukhmanpreet Kaur,
Present, ma'am.
Sukhpreet Kaur,
Present, ma'am.
Sumanpreet Kaur,
Present, ma'am.
Vanshika,
Present, ma'am.
Bhavesh Chopra,
Ma'am, he is present. His mic is not working.
okay, he can type in his response in chat box.
Ma'am, he has
Manveer
typed.
Singh, Manveer Singh,
Present, ma'am.
Sarvapuri, Sarvapuri,
Present, ma'am. Present, ma'am. For the fully management.
Sarvapuri,
Present,
Ivjot,
ma'am.
okay,
If Jot present, madam.
Kapil,
Present, ma'am.
okay, Divjot,
Present, ma'am.
Komalpreet,
Present, ma'am.
Navjot,
Present,
Nav,
ma'am.
okay, Navjot Kaur number 2,
Present, ma'am.
okay, Navneet,
Present, ma'am.
okay, Tushar,
Present, ma'am.
Mohit,
Present, ma'am.
Sahil,
Present, ma'am.
Ranveer,
Present, ma'am. Ranveer.
okay, Tanu,
Present, ma'am.
okay, Shehbaz,
Present, ma'am.
Shruti,
Present, ma'am.
Manisha,
Present, ma'am.
okay, Shahina,
Present, ma'am.
okay, Harjot,
Present, ma'am.
Karanbir, Karanbir, okay,
Present, ma'am. Present, ma'am.
okay, Kamar Paul,
Yes, ma'am. Present.
Vikrant,
Present, ma'am.
Manish,
Present, ma'am.
okay, all done. So I saved it at my side just in case if you doubted whether you are being marked absent or present. I'll encourage you to check it at your side under the attendance tab. So thank you for joining me today. Hopefully this session is useful for everyone.
Have a nice day, ma'am. Thank you.
Thank you, ma'am. Have
Take,
a
Thank
nice
you,
day.
ma'am.
take care of
Thank
Thank you,
you,
ma'am.
ma'am.
Have a
yourself
nice day.
and
Thank
see
you,
you
ma'am.
all tomorrow.